Knowing where and when to look is vital to successful performance in many different sports and is especially correlated with experts' superior decision-making. In football, scanning refers to the frequency of information gathering head-eye movements away from and back towards the ball. Scanning has been found to impact the performance of both expert and youth players directly. Thus, the study of visual perception, and scanning in particular, has become a key research area in football, examining performance, talent development, and expertise. In football, scanning will lead to more emerging affordances for the player to act upon. For instance, an attacking midfielder who is about to receive a pass between the midfield and defensive line of the opponent scans their surroundings multiple times in order to detect and choose between the different emerging affordances. Is there space to dribble? Is there a gap to play the ball through to the winger or striker? Is the defender's pressure so tight that the only safe action is to pass the ball backward immediately? The purpose of this study was to examine how the scanning behavior of some of the best elite youth football players in Europe related to players' performance, according to situational, context-specific, and temporal constraints. Methods. The participants were outfield players from the 4 teams who reached the finals in the 2018 UEFA European U17 and U19 Championships. Data was collected by filming the semi-finals and finals of the 2018 UEFA European U17 and U19 Championships. Permission to film the matches was granted by the UEFA. All matches were recorded on-site by a camera. A scan was defined as a self-initiated head movement in which the player's face is temporarily directed away from the ball, presumably to look for teammates, opponents, the referee, or space relevant to subsequent action with the ball. Scan frequencies were assessed by dividing the total number of situational scans by the situational duration. Any scanning activities were registered in the 10 seconds leading up to the receipt of a pass. The scan had to be initiated before ball contact to be included in the analysis. We exclusively measured the number of scans in the attack, meaning that if a turnover occurred within the 10 seconds period, the analysis began the moment the attacking team achieved control of the ball by touching it. The analysis stopped the moment the analyzed player first touched the ball. Furthermore, only situations in which the analyzed player received a pass from a teammate were included in the analysis. Results. The players performed 0.42 per second on average. Comparing U19 and U17 players, we found that U19 players performed significantly higher scan frequencies than U17 players. Pass result. The results show a positive relationship between scan frequency and pass completion rate. Players who played a successful pass performed an average of 0.43 per second before receiving the ball. When players played an unsuccessful pass, the scan rate was 0.36 per second. For forward, we found a significant interaction between scan frequency and successful passes. More specifically, players performed higher scan frequencies before they received the ball when they made a successful short breakthrough pass compared to when they made an unsuccessful short breakthrough pass. No statistical differences on pass completion was found in the other forward pass types. Ball touches. When receiving the ball from a pass, the players touched the ball 5 times on average. The analysis showed that when players performed more scans before receiving the ball, the number of ball touches increased. Body orientation. We assessed the mean scan frequencies for different types of body orientations. Using a linear mixed model, we found that scan frequency was significantly related to body orientation. To determine the differences between body orientations, a post hoc analysis was conducted. The test revealed significant differences between backward and forward body orientation and between backward and sideways body orientation. Thus, the more often a player visually explored his environment, the more likely he was to be oriented sideways or forward rather than backward at the moment he received the ball, partly supporting our third hypothesis that higher scan frequencies would lead to a more forward-oriented body position when receiving the ball. Body orientation in relation to the timing of the last scan was also analyzed. Here, timing refers to the period between the initiation of the last scan and when ball contact is made. The results revealed differences between body orientations related to scan timing. Significant differences between backward and forward orientations were revealed, as well as between forward and sideways. When the last scan was conducted closer in time to the first ball contact, players were more likely to be oriented forward than sideways or backward. A total of 1,453 situations were included in this analysis. Opponent pressure and pitch position. To analyze the relationship between opponent pressure and scan frequency before receiving the ball, opponent pressure was categorized into groups: tight pressure, medium pressure, loose pressure, and no pressure. Using a linear mixed model, we identified an effect for the pressure groups. A Thue post hoc analysis revealed significant differences in scan frequency between tight and loose pressure, between tight and no pressure, and between medium and loose pressure. However, there were no significant effects for age or interactions. Additionally, opponent pressure appeared to vary between different playing positions. However, these differences were not statistically significant. Furthermore, the results revealed that scan frequencies can vary based on the player's pitch position. On average, players who received the ball in one of the 8 central areas showed a higher scan frequency than players who received the ball in one of the 8 outer areas. This result supported our fourth hypothesis that wider pitch positions would lead to decreased scan frequencies. Playing position. In line with our hypothesis, the results revealed that central midfielders performed the highest mean scan frequencies, followed by central defenders, full, and strikers. The first set of analyses on scan frequency and playing position confirmed that players in different playing positions scan with different frequencies. Subsequently, a Thue post hoc analysis was conducted. These analyses revealed significant differences between central defenders and fullbacks, central defenders and strikers, central midfielders and fullbacks, central midfielders and strikers, wingers and fullbacks, and wingers and strikers. Time from scan to ball contact. Finally, the timing of the player's scans was analyzed. Displays the average duration between the different scans in sequential order prior to the player receiving the ball. A linear mixed model revealed that the time of the last scan before receiving the ball differed significantly among U19 and U17 players. U19 players conducted their final scan an average of 1:59 seconds before receiving the ball, whereas U17 players performed their final scan an average of 1:92 seconds before receiving the ball. These results indicate that U19 players conduct their last scan before the first ball contact later than U17 players.